Stars are some of the most mysterious and breathtaking objects in the universe. When we look up at the night sky, it's easy to forget that each tiny dot of light is actually an enormous sphere of burning plasma, many times larger and hotter than our sun. But what exactly are stars? How do they form, live, and eventually die? Today, we're diving into the incredible life story of stars, the engines of the universe. Let's start from the very beginning. Stars are born inside gigantic clouds of gas and dust called nebulae. These clouds float silently through space for millions of years until something disturbs them, maybe the shockwave of a nearby supernova, or simply the cloud collapsing under its own gravity. As gravity pulls the gas tighter and tighter, the center of the cloud begins to heat up. At this point, the object is called a protostar, a kind of baby star that isn't shining yet, but is getting hotter every second. When the temperature inside the protostar becomes high enough, about 10 million degrees, something remarkable happens. Hydrogen atoms in the core begin to fuse together, turning into helium. This process is called nuclear fusion, and it releases an incredible amount of energy. The moment fusion starts, the star officially turns on, shining for the first time. This is the birth of a true star. Throughout most of its life, a star is in a delicate balance. Gravity tries to pull it inward, but the energy from fusion pushes outward. This balance keeps the star stable, sometimes for billions of years. Our sun, for example, has been shining for about 4.5 billion years and is roughly halfway through its life, but not all stars are the same. Some are small, cool, and dim. These are called red dwarfs. They burn their fuel extremely slowly and can live for trillions of years, far longer than the current age of the universe. On the other hand, there are massive blue stars that burn incredibly hot and bright. They use up their fuel so quickly that they might only live for a few million years before collapsing dot as a star runs out of hydrogen fuel. Its life changes dramatically. The core shrinks while the outer layers expand, and the star becomes a red giant. In this stage, a star can grow so large that it swallows nearby planets. If our sun became a red giant today, it would expand past Mercury, Venus, and possibly even Earth. Eventually, the fate of a star depends entirely on its mass. Small and medium-sized stars, like our sun, gently shed their outer layers into space, creating beautiful structures called planetary nebulae. What's left behind is the core of the star, a small, incredibly dense object known as a white dwarf. A white dwarf is about the size of Earth, but contains the mass of a star. Over trillions of years, it slowly cools and fades away, but the story becomes even more dramatic for massive stars. When a star with enough mass reaches the end of its life, its core collapses in a fraction of a second and then violently explodes in a supernova. A supernova is one of the most powerful events in the universe, so bright that it can outshine an entire galaxy for days. This explosion creates almost every heavy element in the universe, including gold, iron, and even the calcium in your bones. In a way, supernovae are responsible for everything around us after the explosion. Two possibilities remain. If the core is extremely dense but not too massive, it becomes a neutron star, an object so dense that a teaspoon of it would weigh billions of tons. But if the leftover core is even larger, gravity wins completely and it collapses into a black hole, a point in space so dense that not even light can escape. Although stars seem eternal, they constantly form, evolve, and disappear throughout the universe. In fact, when you look at the night sky, you're also looking back in time. Because light takes years, sometimes thousands or millions of years, to reach us. Many of the stars you see today might not exist anymore. Their light is still traveling through space long after the star has died. Stars also create the building blocks of life. Every atom heavier than hydrogen, the oxygen we breathe, the carbon in our bodies, the iron in our blood was forged inside the heart of a star or during a supernova explosion. When people say we are made of stardust, it's not just poetic. It's scientifically true. The next time you look up at the night sky, remember this: every star has a story. From the darkness of a nebula to the brilliance of a supernova, stars shape the universe in ways we can barely imagine. They give light, create planets, and even make life possible. And somewhere out there, countless new stars are forming right now, continuing the endless cycle that has been happening since the beginning of time.